Hi and welcome to this video on L'Hopital's rule. This is the fourth example, and yes, there were examples 1, 2, and 3 that came before this along with an explanation, so hopefully you've watched that already and you know what's coming for this problem. If we look at this problem and we try to evaluate this, we are going to end up with a 0 to the 0, which again, I like to write that's bad. It's an indeterminate form for which we cannot apply L'Hopital's rule. Because we have an x in the base and an x in the exponent, we're going to use a logarithmic technique. We're going to let y equal that function x to the x, and then we're going to take the natural log of both sides. When we take the natural log of both sides, we're going to reapply the limit. And now we're going to look at the right-hand side to see if we can get anything that is something we can deal with. If we plug in a 0 again, we get, and we're approaching 0 from the right, we get 0 times, and again, think of the graph for this natural log. You should have this graph memorized. There's our natural log of x. As we approach 0 from the right, we're going towards negative infinity, and we look at this, and this is bad. Again, it's a form, an indeterminate form that we cannot apply L'Hopital's rule to. So we're going to force a fraction here, and the easiest way to do that is to put this x in the denominator. So we're going to use properties of exponents. We're going to rewrite this as the natural log of x divided by x to the negative 1 power, which is the same as natural log of x over 1 over x, and this should seem familiar from a previous example. And we're going to apply the limit as x approaches 0 from the right to the natural log of x over 1 over x, and when we do that we get negative infinity over infinity, which again is an indeterminate form, but it's a good one because now we can use L'Hopital's rule. So we're going to apply L'Hopital's rule to the numerator, and I'm going to go up here with this problem, and we get the limit as x approaches 0 from the right of 1 over x divided by negative 1 over x squared, which simplifies to negative x, so we're going to apply the limit as x approaches 0 to the right of that, which is 0. Okay, now remember though, we're not done. This is equal to this. Okay, so let's think about what we've just done here. We've just shown, and I'm going to move down a little bit to make things clear, that the limit as x approaches 0 from the right of the natural log of y equals 0. Okay, so let's go back to our original problem, which was the limit as x approaches 0 of x to the x, and we said we're going to call that the limit of y. All right, and then we're going to rewrite y in an equivalent form, and the equivalent form that I'm going to choose is going to be e to the natural log of y. Now, here's where this piece of information becomes important. Now we know that this, as x approaches 0 from the right, equals 0. So I'm going to plug that in there, and we get this limit is e to the 0, which is equal to 1. So we are done. Our answer to the original problem is 1. All right, I hope you learned something from these examples. These are challenging. They take practice, so make sure you practice.